3-1 homework. We really didn't complete it all the way yet, but yeah, that's a good plan. Yeah, that's a great plan. I just, I wanted to make sure I wasn't going to go over all this and you had it done and you're like, okay, got it. All right. So 3-1 is, 3-1 is the start of a chapter. We're going to be solving linear systems of equations. So decoding all those words again, we talked about this on Monday, but linear is line, right? So we have linear equations, so equations of lines. And then we have systems of equations. So that means, basically means that we don't just have one equation of a line, we have two equations of a line, and we want to figure out what value of x and y, or values of x and y, make both of our linear equations true. So there's a set of x's and y's that make this equation true, and there's a set of x's and y's that make this equation true, and we want to figure out where they're both true, right? And so we did a little bit of this on Monday, and that's when your calculator was misbehaving, so now it's going to behave and let you graph things, right? And we kind of talked about what that means. So I think we did number 1, so let's tackle number 2, 3, and 4, and they each have kind of a different thing. I think number 2 is just a standard example, but we can kind of brush up on our skills. So number 2, we have two equations. We have 2x minus y equals 4, and we have x minus 2y equals -1. So we want to figure out what value or values of x and y make both equations true. All right, so the technique we are using in 3-1 is the graphing technique. In 3-2, we're going to use algebra. So that's when we're going to get into all the numbers. But in 3-1, we're going to use graphing. So really the algebra that we have to do for this is to get it in the right format so that you can put it in your TI calculator. All right, so we have our first equation here. We have 2x minus y equals 4. So we can't enter that into the graphing calculator as it is because we have to have a y equals to be able to do that. So what we're going to do is we are going to start with our equation 2x, if my pen will work, 2x minus y equals 4. Okay. What do you want to do? Let's send y to the other side. Let's send y to the other side. Okay, so then we have 2x equals y plus 4. My pen works. And then we'll subtract 4 from both sides, and we will get, if my pen works, we will end up with 2x minus 4 equals y. So this is my first equation, is my red equation. All I've done is I've transformed it to make it a y equals. Okay, if you want to kind of test out your skills, you could plot it on your graph so you know the y-intercept is at -4 because I'm in my standard form, right? My y-intercept is at -4 and my slope is 2. So I think you asked this question on Monday, Sarah, which is a good question. I think it was you. You said, what if your slope is just 2? Well, then we can think of it as rise 2, run 1. Okay, so if I'm at negative, oh no, I had this issue the other day. Is it better now? That's not good. Hold on, give me a second. Is that any better? Okay, if it becomes too bad, we'll just, yeah. I think it's because my computer is out of memory, and so it's kind of flipping out on me. So I apologize. My husband and I are going to work on it tonight. We have to delete a bunch of stuff off the computer. Okay, so I think you had asked what happens if the slope is 2. So that means we could do 2 over 1, right? So that means we rise 2, run 1. I have a tiny little graph there. Rise 2, run 1. Rise 2, run 1. Oops, that's not a very good graph on there. So I have my line there, or I can just go into my graphing tool. So in your case, your TI or Desmos, and you can type in your linear equation. So, oh, I think I had Desmos up. So we had y equals 2x minus 4. Oh, here we go. At -4 is our y-intercept. We rise 2, run 1, rise 2, run 1, rise 2, run 1. Okay. So then we have to do the same thing to our other equation, right? So this one will color code in green. It's like Christmas colors. So we need to change this to a y equals equation. All right, this one's not quite as fun because we have a multiply by 2 deal, but we can totally do it. All right, we have our original equation, x minus 2y equals -1, okay? Let's subtract x from both sides, and we'll get -2y, yuck, equals -x minus 1. And then let's divide everything by -2. All right, so we end up with y equals x divided by 2. Oh, and then a -1 over a -2 is plus 1/2. Okay. So then again, you want to go in your graphing tool and graph it. You could type it as y equals x divided by 2 plus 0.5 if you want to do a decimal, or you could put the fraction in there. I'm going to put mine in Desmos. Am I okay? I'm not too robot-y. Okay, so my red line is the first one. The blue line is my Christmas line, my green one, right? And when I graph them, I see that they intersect right here at 3 and 2. Okay, now on your graphing tool, did you get to enter both these in your y equal? So when you have your TI calculator, right, Sarah? Did you put both of these equations in your, like, y1 equals 2x minus 4 and put y2 equals x divided by 2 plus 1/2? Okay, yes, try that real fast. Okay. Let me know when they graph. Okay. Now, if you want, Sarah, so on Desmos, I just click and there I've got my point, right? If you want to find out where that is on your calculator, you're going to hit your second button, that yellow second button, and then you're going to hit the button that says trace, because above there it says calc, like calculate. And then option 5 says intersect. Do you see that? Oh no. All right. Sarah, I just sent you a text on there. Maybe we should just pick back up on Monday. Yes, I am sorry. I know, we're like talking and chatting at the same time, and I sound like a robot. Okay. Let me tell you what. Okay. Okay. Awesome. I don't know if you can hear me, but awesome. Yes. Yes, it is. Thanks. Sorry about that. Bye.